Hi, I'm Professor Angela Rasmussen from the Department of Electrical and Computer Engineering at the University of Utah. Today I wanted to just do a circuit analysis review. So we're going to look at a circuit that has no dependent sources in it first, and we want to solve this circuit to find V2 and the current I1. So on here we notice that, I'm first going to highlight all of the nodes. And so this is my ground node. A is this red wire, and green is going to be B. So every position on this wire is going to be the same voltage. So if I was to measure from this node voltage of A, and I put a positive multimeter wire on there, so my red lead on there, and I put my negative lead onto the ground part of this, I'm going to measure a plus 8 volts on that wire at any point along that wire. By that same method, I'm going to look at this 4-volt battery, and the orientation is opposite. If I put my red wire, which would be a plus, in comparison to ground, I'm going to measure minus 4 volts. So B is going to be a minus 4 volts. So I notice that I2, the current I2, I know the voltage at each node of that resistor, at VA and at ground. So I can define I2 as the voltage of VA minus 0 over 4 volts. I'm going to always pick the positive side of that current and compare it to the negative side. So the difference that I measure is always going to be from the plus side of the current to the negative side of the current. So plugging that in, I have 8 volts over 4 kiloohms, and that gives me 2 milliamps. By that same idea, I can find the current I1. Again, I'm going to start at the positive side of the current, which is VA, and subtract off the voltage that's at the negative side. So I1 is going to be VA minus VB over the resistance of 2K. And in this case, I have 8 minus, and the value there is a minus 4. And so I get 12 over 2K to give me a value of 6 milliamps. So this was one of my goals, was to solve for this I1. Another goal is to solve for V2 oriented as a plus to minus polarity. That means if I take the plus side is going to be my red wire for my multimeter, the minus is going to be the black wire for the multimeter. If I probe that, I'm going to find, using Ohm's law, the voltage at V2. Because I have in this branch a 5 milliamp current, that's going to set all of the current going through this until I reach another extraordinary node. So that means that going through V2, I have 5 milliamps, and the polarity is, the negative is always on the arrow side, and so it has the same polarity as my V2. So it's going to be a plus 5 milli times 1K to give me a value for V2 of 5 volts. So these were the two values that I wanted to solve for this circuit, but I wanted to go one step further. If you did want to find an unknown current, say I8V, which is here, I could do a node voltage summation at that node B, at the node A, to solve for that. So remember, for node voltage, the definition is that we take currents always going out of the node, and so all of our directions are going to be out of that node. So we notice that in that branch, I1 is going in the same direction. So we are going to have the node voltage equation at A is going to be a plus I1, which is plus 6 milliamp, out of A in this branch gives me, I see that the 2 milli is opposite that. So that gives me a negative 2 milli because it is opposite. Into this branch is the same direction for I2, and I2 was 2 milli. And then I8V is already drawn there, but I want to take the current going out of that node. So I define that as a minus I8V. So that equals 0. And I get I8V is going to be 6 milliamps. If I didn't want to solve for I1 and I2 first, I could write this node voltage a little different, and I could say that it was I could take this one first, and it would be a minus I8V. Then I would take I2, which would be a VA over 4K. And I could take this one, which would be a VA minus VB over 2K. And then this branch will have a minus 2 milli equals 0. And then I would need to know VA, which we did define as 8 volts, and a VB as a minus 4 volts. And then I could plug those in and still solve for I8V. With the 3 unknowns in this, I need 3 equations. So this would be an unknown, this would be an unknown, and then VB would be my other unknown. So 3 unknowns means I need 3 equations, and in this case that would be equation 1, equation 2, and equation 3. This concludes this video. Thank you for watching.